Okay, so for the activity that we're going to do today, you're going to need some materials. We're going to walk through it right now, and I'm going to give you a little example so you know what to do when it's time. First of all, you'll notice you need a sheet for your group. Okay, so your group might be group 1, 2, 3, 4, or 5. This one says example group. This group has 3 equations. Yours will probably have 4 or 5, but you may only want to work with 3 of them depending on how many people end up in your group. So you'll need that. You'll also need for each person in your group one of these. This is the sheet that you're going to be working on. Each person in your group needs to complete one of these, and each one will look different when you're done. So you'll need, for this group, 3 of those. Okay, set this aside. We're also going to need, for each person in your group, a clear transparency with graph lines on it. I know this, sorry about the light, it's a little glary in here, but you'll need one for each person in your group. Oh, I've got 4. I only need 3 for this group. And then you'll need a ruler, and you'll need a dry erase marker, and you'll want something to write on your paper with. You can just use a pencil. I'm going to use this pen because it'll be easier to see on the camera. All right, let's get started. First thing you do when you get into your group is you're going to look at your sheet, and you're going to need to decide which person is which. So you may want to just go ahead and write that right on the sheet. Okay, so we could say this is going to be Bob. This is going to be Tina, and this is going to be McGillicuddy. All right, so that you know who's doing which equation, and later when I go back to grade the assignment, I also know who's doing which equation. All right, so once you've assigned group roles, each person in your group will need to take one of these, and the first thing you'll do is you'll write down your equation. So for example, this is Bob, right? He's going to put the date on here. Let's see, it is 14. He's going to say, I chose equation example A, so EXA, okay, which is 2y minus 3x equals 12, all right? All right, the next thing you're going to do is sort of set this aside. Now that you know which equation you're working on, you're going to pull out your graph paper. If you're working on your desk, you may want to put your whiteboard underneath it to give it a nice white background. For me, I've got this all set up. Okay, make sure you can see. Good. All right, now I'm going to go ahead and I'm going to write somewhere on my sheet that this is example A. That's going to be helpful later when you're working with other people. And your job is to graph your equation. So since Bob's equation is 2y minus 3x equals 12, it's a good idea to go ahead and write that down. There's a couple ways to graph things that we know about, right? You could make a set of points, you could find the x and y intercept, and you can also put it into slope-intercept form. I'm going to both find the x and y intercepts, and I'm going to put it into slope-intercept form. All right, so 2y minus 3x equals 12. Well, if I made y 0, right? If I made y 0, this term would go away. I'd end up with negative 3x equals 12. I could divide by negative 3. And then I'd get x equals negative 4. So I know one point on my line is going to be y equals 0 and x equals negative 4. 1, 2, 3, 4. So that's going to be one point on my line. Now if I made x 0, this term would go away, and I'd get 2y equals 12. So that means that I can divide by 2, and I end up with y equals 6. So I also know that on my line will be 1, 2, 3, 5, 6. That's going to be a point on my line. Now, I could just connect those dots and I'll probably get the right line. But when we're working with kind of big fat markers and a slippery surface, sometimes it's good to have more than 2 points. So I'm just looking at quick, and I'm going to figure out the point slope form as well. I mean slope intercept form, excuse me. So I've got 2y minus 3x equals 12. I'm going to go ahead and take this over here. So I get 2y equals 3x plus 12. And then I'll need to divide everything by 2. So I get y equals 3 halves x plus 6. Okay, now look, there's that y-intercept again, right? That's already on there, which is great. That's a sign that I'm doing the right thing. And then my slope is 3 halves. That means I go up 3 over 2, up 3 over 2. Great, that's on my line, up 3 over 2. So the other advantage to this is you get to check your answer. Over 2, down 3, 3, and we can work our way down. And now I know when I draw my line with my ruler that I've got to hit all those points. It helps, by the way, with this hand to stretch it out and hold the ruler as tight as you can. Otherwise, it might slide around a little bit. Okay? And now I've got my line. All right, so that part of the job is done. Now, Bob can't do much else until the next member of his group completes their graph. All right, so now we fast forward just a little bit. We've got Bob is done with his graph. We've got Tina is done with her graph, and they're in the same group. They're now going to share their graphs in order to do the problems that we have over here. So first thing, we're on Bob's sheet, okay? And Bob knows his equation already, and here it says system 1, my equation. So he's going to rewrite his equation. 2y minus 3x equals 12. And then he's going to say other equation. Now you can do this in any order, but it's important that you note which equation you're working with. So he's example A, that's Bob. The other equation for Tina is going to be example B. Okay, and Tina's equation is here, 5x plus 3y plus 39 equals 0. Now, they're going to find their point of intersection. The way we do this, now that we have these nice graphs made, is pretty simple. We overlay one on top of the other, make sure the x and y axis are lined up nice and tight. Okay, they should be just right. And we should be able to see where there's a point of intersection if there's a consistent system. Okay, if it's an inconsistent system, obviously they will not intersect, as we just discussed. The point of intersection for this one is, let's see, the x-coordinate is 1, 2, 3, 4, 5, 6, -6, and then -3. So they'll write -6, -3. Now notice Tina is doing the same thing on her sheet. Her equation is 5x plus 3y plus 39 equals 0. Sorry for my handwriting, it's tough with this tiny pen. And she's example B already. She's working with the other equation, which is going to be EXA. Okay, that's Bob's equation, right? And Bob's equation we said is 2y minus 3x equals 12. But their point of intersection is going to match, right? -6, -3. Now the work that you're going to do here is checking to see whether this point of intersection actually satisfies your equation. Or in other words, when you plug in these values for x and y, does this become true? So let's take a look. We've got 2y minus 3x equals 12. 2y minus 3x equals 12. So for the y, I'm plugging in -3. So 2 times -3 minus, and for the x, I'm plugging in -6. 3 times -6 equals 12. Let's see, let's check and find out. This is -6. And this is minus -18, which actually becomes plus 18. So -6 plus 18, and that does in fact equal 12. So that means this point of intersection does satisfy my equation. Over on her paper, Tina's going to be doing the same thing. She's going to be checking to make sure this satisfies her equation. Her equation was 5x plus 3y plus 39 equals 0. And she wants to make sure that this is actually a point on her line. So she's going to plug these in. She's going to say 5 times -6 plus 3, 3 times -3 plus 39 equals 0. And let's see if this is true. 5 times -6, that would be -30, plus 3 times -3, that would be -9, plus 39, and let's see, -30 and -9, that's -39. Oh, -39 plus positive 39 is equal to 0. Check it out. These both are satisfied. So Tina and Bob have worked together here, and they found out, oh, the point -6, -3 is in fact a solution to both of their equations. It's a set of x and y that makes them both true. That makes them an intersection, and it makes them a solution to the system of equations they just solved. Once Tina and Bob are done here, they're going to go on and pair up with somebody else in their group and complete the other boxes.